The new Razer Blade Pro 17 gaming laptop is a thin machine with some powerful specs inside. So just how hot does it get? And is there any throttling? In this testing, I'll be taking a detailed look at thermals and seeing how much we can improve performance with some simple tweaks. The Razer Blade Pro 17 is available in different configurations. My model has the Intel i7-9750H CPU, 100W NVIDIA RTX 2070 Max-Q graphics, and 16GB of memory running in dual channel, so expect different results with different specs. You can find updated prices for different models linked in the description. On the bottom, we've got air intake vents over all 4 fans. Yes, that's right, 4. While the back behind the rubber is the air exhaust. The rubber feet at the back actually raise it up quite a bit, which should aid airflow, and also help reduce the intake fan sucking the exhausting hot air straight back in. Inside, we've got Razer's vapor chamber cooling over the CPU and GPU dies, while the 2 fans at the front don't appear to be connected, so they're just helping to bring more air into the system, which is always welcome. By default, Razer has actually undervolted the laptop by minus 0.1 volts, which is great to see. So we are expecting above average results compared to the competition at stock. This was only to the core voltage offset and not the cache. I have also manually undervolted a little further with Intel XTU, pushing it to minus 0.15 volts. However, when doing this, the cache voltage is linked to the core voltage offset. So with my manual change, both values were modified, whereas Razer are only changing one. In Razer's Synapse software, you can either set balanced mode or optionally set fan speed at maximum or instead select custom. I've tested with both, but while testing custom, I've set both CPU and GPU to high, and I found doing this to the GPU would overclock it by 100 MHz on the core and 400 MHz on the memory. Unfortunately, it does appear we're limited here in that we can't manually set the fan speed to maximum like we could in balanced mode. Which seems a bit strange. These custom higher performance options are where we would want higher fan speed. Thermal testing was completed in an ambient room temperature of 21 degrees Celsius, so expect different results in different environments. I've tested idle down the bottom and it was on the warmer side. Not really an issue though, as this was because the fans were completely silent. The rest of the results are from combined CPU and GPU workloads and are meant to represent worst case scenarios as I ran them for extended periods of time. The gaming results towards the upper half of the graph were tested by playing Watch Dogs 2, as I find it to use a good combination of processor and graphics. The stress test results shown on the lower half of the graph are from running the AIDA64 CPU stress test with only the stress CPU option checked, and the Heaven GPU benchmark at max settings at the same time to fully load the system. Let's start with the stress test results in balanced mode. So keep in mind this still has the default minus 0.1 volt undervolt on the CPU. And temperature-wise, this looks fine. When we enable the custom mode with the CPU and GPU set to high, we see an increase in CPU temperature, as this raises the power limit of the CPU, and more power equals more heat, but better performance. The GPU drops back a degree as this also raises the fan speed, as you'll hear soon. And this is despite the GPU overclocks that this is applying. By undervolting the CPU a little further, it was possible to lower the temperatures a bit more. And then with the cooling pad, it was possible to get a slight improvement. The gaming results saw a similar pattern, however the temperatures of the CPU were a bit cooler in this particular game compared to the stress tests. But results will always vary by game. These are the average clock speeds for the same tests just shown. With balanced mode, we're seeing lower levels of CPU performance due to the power limit it sets. With the stress tests running, simply enabling the custom settings to boost the CPU power limit is enough to get us 700 MHz extra on all 6 cores. It didn't go further due to power limit throttling. This is why in the next result, when the CPU undervolt is pushed further, we're now able to hit the full 4 GHz all-core turbo boost speed of the i7-9750H. As thermals were already under control, by this point the cooling pad made no real change. The gaming tests on the other hand were pretty similar. Though we saw more of an increase to the GPU clock speed here, as the GPU was constantly power limit throttling during the stress test, which seems to be why the clock speed didn't raise even with the overclocks applied from the custom settings. Don't panic though, power limit throttling on the GPU happens on pretty much all RTX laptops I've tested in this workload. You should be able to improve that with undervolting. These are the average CPU TDP values during the same tests, and we can see why balanced mode was behind. It's setting PL1 to 35 watts, while custom mode limits the CPU TDP to 55 watts. These are the average CPU clock speeds while under a CPU-only workload. While balanced mode caps the CPU power limit to 35 watts, we can still reach higher clock speeds with the available power by undervolting further. We couldn't quite hit the full 4 GHz all-core turbo speed of the 9750H in this workload with custom mode. However, my little extra undervolting did get us all the way there. Here's how these tests look in terms of temperatures. Again, the extra undervolting is improving thermals as well as clock speed. This is because less power equals less heat, as doing this generally lowers CPU TDP. To demonstrate how this translates into performance, I've got some Cinebench CPU benchmarks here. In this workload, the average result, even with the custom settings enabled, seemed a little behind the few other 9750H machines I've tested, but the additional undervolting helped. So there's not too many extra changes we need to make due to the default CPU undervolt and GPU overclock. But let's see how these changes improve performance in games. I've tested Far Cry 5 with the built-in benchmark at 1080p, and the red bar is with my extra CPU undervolt, so minus 0.15 volts on both the core and cache, while stock is just minus 0.1 volts to the core only, which is the default. There's not really a difference here. In fact, my changes are actually slightly worse in all cases. I've also tested balanced mode out in the green bar, and as we saw earlier, this mode does run warmer, but it's not actually performing all that far behind. And just to confirm, the default undervolt still applies in this mode. You'll hear shortly how much quieter balanced mode is, so it's a good option if you don't want loud fan noise while still performing quite well. If you're after more gaming benchmarks from the Razer Blade Pro 17, check the card in the top right where I've tested 20 different games. As for the external temperatures where you'll actually be putting your hands, at idle it was a bit warmer than usual, probably due to the warm internals combined with the metal body. While gaming in custom mode, which was running the fans at maximum, the keyboard and wrist rests were fine, just a little warm. Similar results with the stress tests running, though hotter up the back, however you shouldn't be touching there. This is the same test with the fans at maximum now, but also higher levels of performance. We can see the air is exhausting out the back below the screen, partially heating the screen, so it'll be interesting to see how that holds up long term. As for the fan noise produced by the laptop, I'll let you have a listen to some of these tests. At idle, the fans were completely silent, which explains the warmer idle temperatures. That'll always be a trade-off. In balanced mode, it was noticeably quieter compared to most other gaming laptops I've tested. Though again, that's another trade-off with lower performance as we saw earlier, but you do at least have the option of running it quieter. Under stress test with either balanced mode and the fan manually maxed out or in custom mode, it was running at the same level. And this was now pretty similar to most other machines I've tested under this same workload. Overall, I was quite happy with these results from the Razer Blade Pro 17. It was warmer than usual at idle, but to be fair, the fans were stopped. Not really an issue idling a little warm anyway. Balanced mode offered a good way for us to limit performance if we want to stick to lower fan speeds, while custom mode gave us nice performance improvements. While gaming at all times, I didn't consider the temperatures hot, as it didn't get to 90 degrees, at least in the specific game I was testing with. This did happen with the stress tests once the custom settings were enabled. However, as we saw, it was possible to improve thermals with further undervolting or by using a cooling pad. It's worth keeping in mind that both the CPU and GPU are allowed to run above spec, up to 55 watts on the CPU and 100 watts on the GPU. So while this will give us extra performance, it also results in extra heat. But despite these higher limits, it seems to be handling it alright. With regards to the default undervolt, I'll also note that after resuming from sleep or hibernation, it was no longer applying until I rebooted the machine. The undervolt is definitely default by Razer, as it keeps coming back even after a fresh install of Windows and setting the BIOS to defaults. The 230 watt power brick included by Razer with the Blade Pro 17 seems to be adequate. While running in custom mode, so with the highest CPU power limit and graphics overclocked, the battery did drain to around 95%, but I didn't see it drop below this. These differences in performance shown aren't hard and fast rules. There are different factors which will vary results, primarily the temperature of the room you're running in, application of thermal paste, and even the specific hardware, which comes down to the silicon lottery. You may not be able to undervolt or overclock your hardware the same as me. It depends on the chip and its specific power requirements, so don't just blindly copy my settings and do some testing to find out where your stable point is for best results. In the case of Razer's stock out-of-the-box undervolt though, in my case it did appear to be stable. I didn't have any issues with it. It may be possible to further improve temperatures by swapping the thermal paste. However, as this is a review unit that I have to send back, I'm not able to change the paste. Otherwise, the next reviewer will unknowingly report different results due to what I've done. Additional undervolting, boosting the fan speed, or using a cooling pad are much easier for most people to do anyway, and as we've seen, these tweaks did help improve performance of the Razer Blade Pro 17 gaming laptop. So what did you guys think of the thermals from Razer's new Blade Pro 17 gaming laptop? It's going quite well after some small tweaks. It's kind of hard to really measure if the 2 extra fans towards the front are helping much. But it's good to see that they appear to be taking cooling seriously with this change, and also undervolting out of the box. Let me know your thoughts down in the comments, and if you're new to the channel, you'll definitely want to get subscribed for the upcoming full review of the Razer Blade Pro 17.